right, 7-6, video take 2. My dog decided to stand in my light for the other video, so we're redoing this one. All right, we are factoring your difference of squares today. So this is leading you into what we're going to be doing. Today's lesson is fairly straightforward. It's relatively simple. We're going to start by foiling. If you remember foiling, and these are called warm-ups, first, outer, inner, last, but you're distributing. So x times x gives you x squared. X times -4 gives you a -4x. 4 times x gives you a positive 4x. And 4 times -4 gives you -16. Then you have to combine like terms. You've got a -4x and a positive 4x. Those are going to cancel, and you're going to be left with x squared minus 16. There we go. So again, 5m times 5m gives you 25m squared. 5m times a -1 gives you a -5m. 1 times 5m gives you a positive 5m. And 1 times -1 gives you -1. Combine your like terms. -5m plus 5m, that cancels. You are left with 25m squared minus 1. And your last warm-up. 2a times 2a is 4a squared. 2a times a -3b is a -6ab. 3b times 2a is a positive 6ab. And 3b times a -3b is a -9b squared. Combine your like terms. Have you noticed that I'm circling the middle two terms on each one of these? If you are distributing correctly, meaning you're taking the first times the first times the last times the first, and the last times the last, you're always going to have your middle terms being your like terms, and those are always what's going to cancel. So, and you're going to have to excuse the marks on my paper. One of my children got a hold of it. I apologize. What we have been doing is going from here to here. What we are doing today is going from here backwards. These are what are called a difference of squares, and they're very self-explanatory. Difference is subtraction. Subtraction, subtraction, subtraction. Squares are perfect squares. Well, x squared is a perfect square, 16 is a perfect square. So to factor these, first you have to make sure that you have an actual difference of squares, meaning perfect square, subtraction sign in the middle. You use the following rule to factor. A squared minus b squared factors into a plus b, a minus b. And then you can check your work by distributing. So factor each difference of squares, check your work by distributing. If a polynomial cannot be factored, write prime. If you're looking at number 1, a squared is a perfect square. 4 is a perfect square. There is a subtraction sign between them. So this one factors. So we're going to start by making 2 sets of parentheses. A squared splits into a and a because a times a is a squared. 4, well, what's the square root of 4? It's 2. So you've got 2 and 2. Now, this says you got to have, this says you got to have a plus sign and a minus sign. So we're going to have a plus 2, a minus 2, and that's going to be our answer. We're doing this over and over again, guys. So number 2, is n squared a perfect square? Yes. Is 64 a perfect square? Yes. Is that a subtraction sign? Yes. So make your 2 sets of parentheses. N squared splits into n and n. The square root of 64 is 8, so 8 and 8. Put a plus sign in there and a minus sign in there. Box it in, move on with your day. So if you notice, number 3 is written backwards, meaning our number is written first and our variable is written last. That's fine, but your parentheses have to follow the same order. So is 81 a perfect square? Yes. Is x squared a perfect square? Yes. Is there a subtraction sign in between them? Yes. So 2 sets of parentheses. The square root of 81 is 9, so 9 is going to go first. The square root of x squared is x. It's going to go last. Then you got to have a plus sign and a minus sign. Aren't these boring but yet satisfying? Because I think they are. Number 4. Perfect square? Yes. Perfect square? Yes. Subtraction sign? Ding, ding, ding. So 2 sets of parentheses. No, that's not enough space. The square root of c squared is c, so c and c. Square root of 100 is 10. 10 and 10. Plus 10 and a minus 10, and we are done. So, number 5, perfect square. Yes. Perfect square. Yes. Subtraction sign. That's a no-go. See that? That right there? That makes this prime. You cannot factor it if it's got a plus sign. That is a no-go, Ghost Riders. Number 6, perfect square. Yes. Perfect square. Yes. Subtraction sign. Yes. So that factors. 2 sets of parentheses. 1 splits into 1 and 1. 49y squared splits into 7y and 7y. Then you got to have a plus sign and a minus sign. So number 7, perfect square. Yes. Perfect square. Yes. Subtraction sign. Yes. So 2 sets of parentheses. 9b squared becomes 3b and 3b. 100 becomes 10 and 10. Got to have that plus sign and that minus sign. Number 8. Is that a perfect square? Yes. Is that a perfect square? Yes. So is that a subtraction sign? Yes. Go ahead and split. 25x squared splits into 5x and 5x. Remember, you are taking the square root of these numbers, not just dividing by 2. The square root of 49, 7 and 7. Got to have a plus sign, got to have a minus sign, and that's it.
I have to get my phone and take it out.
No. Go put it back, Jordan, now. So number 9, we're going to skip just because it's repetitive of what we've been doing. Number 10, we're going to go ahead and go over just because if you notice, you've got 2 different variables now. That does not change what we're doing. It just adds something else inside your parentheses. So perfect square? Yes. Perfect square? Yes. Subtraction sign? Yes. So break it up. X squared splits into x and x. 81y squared splits into 9y and 9y. You're going to have a plus, you're going to have a minus, and that's going to be it. So number 11 is 4h squared a perfect square? Yes. Is 25g squared a perfect square? Yes. Is that a subtraction sign? Yes. So go ahead and break it up. 4h squared splits into 2h and 2h. 25g squared splits into 5g and 5g. You're going to have a plus sign and a minus sign. We'll go ahead and do it. Perfect square? Yes. Perfect square? Yes. Subtraction sign? Yes. So go ahead and make your parentheses. 64u squared splits into 8u and 8u. V squared splits into v and v. So 8u plus v, 8u minus v. Next page. Or I guess the back of the page. All right. Number 13. This one's kind of interesting. You've got x squared, y squared minus 1. Well, both of these have an exponent of 2, right? That means that's a perfect square. Is 1 a perfect square? Yes. Is that a subtraction sign? Yes. So x squared, y squared is going to split into xy and xy. 1 splits into 1 and 1. So you're going to have xy plus 1, xy minus 1. Number 14. So at this point, you've got a 4, a 4, a 4, a 4, a 6, a 6 and a 6. As long as you have an even exponent, you have a perfect square. So is 81 a perfect square? Yes. Is 25 a perfect square? Yes. Go ahead and draw your parentheses. 81 splits into 9 and 9, but I've got into the 4th, so it's half of 4. Well, 2. So I've got 9n squared and 9n squared. Square root of 25 is 5. So 5 and 5, I'm going to have 9n squared plus 5, 9n squared minus 5. Number 15. Is that a perfect square? Yes. Is that a perfect square? No, it's not. See that? 5 is definitely not. So if it's not a difference of squares, you write prime. Do, 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 do. And you move on with your day. So 16, 49m to the fourth, is that a perfect square? Yes. Is 16 a perfect square? Yes. Is that a subtraction sign? Yes. So go ahead and split. 49m squared becomes 49m to the fourth becomes 7m squared. 7m squared. 16 becomes 4 and 4. We're going to have a plus sign and a minus sign. And I'm knocking stuff over. All right, 17. That's an even exponent right there. So we can go ahead and split this up. So, oh, sorry. That's a perfect square. That's a perfect square. That's a subtraction sign. So k to the sixth, what's half of 6? 3. So that's going to become k cubed and k cubed. 16 splits into 4 and 4 plus minus. I think we can skip this one because it's a lot like this one. We'll go ahead and do this one. So it's another 6 exponent. Is 121 a perfect square? Yes. Is 1 a perfect square? Yes. Is that a subtraction sign? Yes. So the square root of 121 is 11. So you're going to have 11r cubed and 11r cubed. The square root of 1 is 1. So you're going to have 11r cubed plus 1, 11r cubed minus 1. And 20, and then that'll be it for this half of the lesson. So 20, 64m to the fourth, that's a perfect square. 9n squared, that's a perfect square. You've got a subtraction sign, so break it up. 64m to the fourth splits into 8m squared and 8m squared. 9n squared splits into 3n and 3n, plus sign, minus sign. And that's all for today.